So the Sinclair on Cambridge Mark 14 was out in 1978. Mort's going to tell you about what happened to my Mark 14. I threw it out in a house move, and after that I really regretted throwing it away. So I made a copy, and I'll be talking about the copies that I made as well. So I apologise about that in Spanish. If you have any questions, please, I'm very happy to make this interactive as we go along. So that's the machine, as we see across the way, all the Sinclair family. So lots of people, those from here onwards in the Sinclair families, these are pretty famous, and I've been hearing that in Spain the Spectrum was particularly popular. The first of these was the Mark 14. So I guess you're here, so you all heard of the Mark 14 before today. Did you know about the Mark 14? You didn't? Okay. It's kind of Sinclair's secret machine. Maybe you did, maybe you went fail. So it evolved. So his most famous computers were all based on Z80. And the last machine that was based on the 68,000 architecture. This one was based on a microprocessor called SCAMP, a simple cost-effective microprocessor. And if you look at what happened to microprocessors, the 1970s was really a golden age. So before the 1970s, if you wanted a computer, you either had to buy a mainframe or you had to build devices out of TTL chips like Digital Equipment did, for example. And then Intel, in 1971, for a Japanese calculator project, made the very first integrated CPU, integrated microprocessor, which was the 4004, and it was a 4-bit microprocessor, and had a gate count of a small number of thousands. And this was very popular. So Intel went on to make the 8080, which was really popular in the 1970s, and the first US home computer, the Altair, was based on the 8080, S100 bus. Motorola made the 68000, which we saw went on to make the QL. 6502, of course, like BBC and well, single-board computer, I was hearing about a little bit earlier on. And Z80, of course, as well, a little bit later, 1976. But the cheapest one of these was the SCAMP, Simple Cost-Effective Microprocessor from 1974. And National Semiconductor produced this, made a low-cost development system for engineers to learn how to use microprocessors, and they made one of these, the intro kit. And the intro kit, and there's one across the way, if anyone wants to see one, launched in 1976, based on the first version of SCAMP. So it's 1 megahertz, very slow, and the internal architecture is bit serial, it's not parallel architecture internally, so it's very, very slow, it takes lots of clock cycles to do something, but it was very cheap. And this trainer kit had 512 bytes of ROM and 256 bytes of RAM. Tiny, tiny, tiny system. And the original kit was designed to use for a teletype, just like mainframes were at the time. But you could buy an optional add-on, which is this bit here, which is wire wrapped, you have to build it yourself, and that would connect to a calculator like displays, calculator keyboards, calculator displays sitting in here. This would have been hundreds and hundreds of pounds, still quite expensive, and crashed the marketplace. So enter Sinclair. So we all know Clive Sinclair, and perhaps you know Chris Curry, who also worked in Sinclair Electronics. And Chris Curry, who went on to found Acorn Computers, thought there might be a market for a home computer. So he looked at that intro kit from National Semiconductor, and made it cheaper, like Sinclair always made things cheaper. So when it was launched, it was £40 plus that, or £215 in today, £205 in today's money, which is what, a little bit under €300. So for the time, this was very, very cheap. And I saved up my pocket money, and I bought one of these, and this was my first computer I ever had. As I said, very slow, flat out, the fastest thing you could do was 0.2 MIPS. Comparing contrast that with the slowest processor today, thousands of times faster. 256 bytes of RAM, 512K of monitor, so 512 bytes. The monitor program is exactly the same as the interkit, byte for byte, the same piece of code. Tiny little calculator display, because it was cheap, the Sinclair were making lots of calculators, and it was sold as a kit, so you had to solder it together yourself. And some people sold them together well, and some people sold them together badly, which means you can't find many good examples today. that are dealing with national semiconductor. So all the chips in here came from national semiconductor. It's got a cheap price again, Sinclair saving money. And it proved to be very popular. So Chris Curry and Clive Sinclair thought they might sell 2,000 of them. They actually went on to sell 30 to 50,000. So it's very popular. However, didn't have any mass storage. You type the program in on the keyboard, and when you took the power out, the program disappeared. And the keyboard was terrible, really dreadful. So again, Sinclair trying to save money. The idea was good. So instead of having mechanical switches that are expensive, he put contacts on the PCB, and then some plastic, and then a rubber sheet which was loaded with graphite, so it conducts electricity. Now here was you push your finger here, which pushed the conductive rubber through the hole onto the PCB. But if you used the wrong kind of rubber, it didn't work. It really didn't work. So actually, if you look at the boards, Sinclair didn't work. This connector here is for adding an external keyboard. So the first thing anybody ever did with one of these was to make the keyboard look like this. So my Mark 14. So this is the only photo I could find. So this is my bedroom in about 1978. Some interesting things here. You see the paper tape reader there? And some amateur radio stuff. The stuff up here is my computer corner. So I made a case for it. So the actual Mark 14 is sitting inside that. And then this is the keyboard that I made to add on to it. Another system here, this is the NASCOM one. If you've ever heard of NASCOM? No. Maybe not in the Spanish marketplace. So that was where I bought after Mark 14. It didn't work when I sold it together. And the problem was I was using a halfway rectified power supply. And Sinclair, again to save money, there's a space here for a smoothing capacitor to smooth out the power supply, but to save money, he didn't supply that as standard. So what happened, I connected it up to my power supply and it would work for 40 milliseconds, switch off, and then start working again for another 40 milliseconds. Fortunately, I had a friend who was an electronic engineer. He said, you need a smoothing capacitor, got it to work. So it taught me how to program, taught me how to solve it, and it taught me about the basics of microprocessors. And I find there's a lot of people started their career in electronics and computing with these machines back in the 1970s. So what happens to my Mark 14? So this is my theory of what happens to technology over time. So you buy something, and it's new and shiny, you pay full price for it in the shops, and it kind of gets middle age, and you might be able to sell it second hand, and it turns into useless junk. So I moved house when the Mark 14 reached this part of the cycle, and I threw it away. However, sometimes things become collectible, then they become valuable plastic and they go up in value again. So an Apple I, for example, if you have an Apple I, they sell for between $500,000 and $1 million at auction now. So Mark 14 is not quite that valuable, but here's one that just sold on eBay, and there's not that many that come up on eBay. So this is about €1,000, over €1,000. So pretty expensive now. So I decided in about 2000 something that I wanted a copy of my first computer again. I really missed it. But what should I do? Should I buy one from eBay? So expensive, not going to come up. And because people have sold them together themselves and then thrown it in their loft, often they're in very poor condition. Then it has a keyboard that doesn't work. It's only got a very small amount of memory. So should I make one? If I made it, why would I make it? So in high quality, that more memory, have a keyboard that works, maybe I can make the memory non-volatile, so I wouldn't have to keep typing things in every time I use it. Maybe better display, and chance to play with hardware, which is kind of fun, might be cheaper, and it's hard, and I like hard things. So I decided I was going to make one. What should I do about it? So I originally decided I'd keep the same CPU as the original had. So exactly the same, find some hardware. Keep a compatible memory map so all the old programs will run okay. Make the storage non-volatile. And then add multiple memories, memory maps, and larger memories as well. So you can do everything the original did, but other things as well. Good quality keyboards. Couldn't make up my mind about whether to use original display or a modern replacement, so I decided to do both. And then all the glue logic The original had 10 TTL chips to do the memory decode and handle the keyboard and display, and decided to put that in a programmable device, so I could change it and it would make one chip. Where to find stuff? So the microprocessor, the SCAMP2, is now running at 4.43 MHz, and the I/O chip looked on eBay, and also there are, I never knew this until I started this, there are brokers that deal in obsolete semiconductors. So I managed to buy a bunch of both of these chips from some brokers. Displays a bit harder. So a modern display obviously you can just buy from the supplier, and an original display hard to find. And I found a second-hand store in Australia that had a large stock of these. I bought the stock they had. So that was that problem solved. Keyboards. So I could buy a keyboard switch, but how to make the lettering look good and high quality. So again, I discovered you could laser engrave them. So I got a company to do some laser engraving of the keys. And then for the memory, half a megabyte of RAM, half a megabyte of flash, with plenty of space to emulate the original Mark 14. And then I had to solder this together. So modern devices have very small leakage, hard to solder. And I figured that SOP with a 1.27mm pin space was about the finest pitch I could actually solder. Talked about the glue logic. So after having thought about everything that goes in there, one of the problems is 5-volt I/O. There's a lot of FPGAs now at 3.3-volt only, and it had to be something I could solder, and something I could program. So I settled on the Altera 7000 series because it met those criteria. So memory maps. So I ended up with 16 different 4K memory maps. So it keeps the original memory mapping, but adds extra RAM to it. So all the original software would run just as it did. And then there's a second mode, which has just about 32K of ROM and 32K of RAM. So you can run basic and stuff like that in there. And then on the board, there's a little switch that lets you choose which memory map that you want to have. So a bit hard to see on here. I used Eagle CAD package to design the hardware. Sent it off on the internet, made in California for me, this original one. And that's the board that you can see there. That's what it ended up like. We'll come back to that in a minute. Here's my FPGA, which is CPLB. Here's the original processor. Here's the I/O. A little patch panel if I want to add some more hardware into it. Here's my board and my bits. And then this is what the finished result looked like. So here's the one with the original display I got from Australia, and here's the one with the more modern display. I almost got the design right first time. What I didn't know was there wasn't any pull-up resistors internal to the FPGA, so I had to put some on the board. But apart from that, it worked perfectly first time. And I made websites about it, and somebody contacted me. Please, you have a question? No. Somebody contacted me through a website and said, would you like my Mark 14? Of course I'd like your Mark 14, thank you. So this is what arrived. So it was incredibly dirty, you can't really see that very well on the slide. Bits broken off it, no I/O chip, absolutely filthy. So I stripped it back just to bare PCB, glued it all up, and then I bought some original components and soldered it all back together again. This is what's going to show across the way. So people said that's pretty nice, but couldn't you emulate it in a modern microcontroller? So remember the original processor is very slow. So the first version I made was based on PIC, and it simulated base level Mark 14, only 256 bytes of RAM. The eSquared component we used to make the memory non-volatile, and you can connect it to PC for software download. So it worked, but I'm not a great fan of the PIC architecture. And also it's a bit limited, I want to make something a bit more memory now. So I thought I'd make an AVR version, and that means we can have 2K of RAM, again same non-volatile features, speed the same as the original Mark 14. And the hardware's all done, you can see it across the way, and that's what the kit looks like. So PCB, a set of components. However, I haven't finished the software, and I have no time. So if anybody's interested in writing software, then it'd be very interesting to have a conversation with you about whether we can get this finished. So at the show, we've got the original Mark 14, we've got my reproductions, we've got the intro kits, and then we've got the PIC and ADR-based versions. And what do I want to do? So apart from finishing the software for the ADR version, Sinclair made an add-on VDU, so with a heavy resolution 32 by 16. So I'd like to connect that up. Something to do. I'd like to put a basic interpreter on it. I'd like to make a hex loader. Probably some kind of radio controlled clock. And I'd like to make kits available because I think these are fun. So you think about what goes into all this. You learn a little bit of soldering, have a bit of fun playing games on it, and then maybe you can learn a bit about programming as well. It's a good educational thing for people to try. That's it. So I apologize about the Spanish. Anybody any questions or comments?
The original design has video means video display unit. The original one had the display unit as option.
So you can buy options. So yeah, I think you paid another £30 or something. You can buy a VDU card. But the interface wasn't very well thought out. You had to cut PCB tracks and you had to solder lots of wires on. So I have one, but I've never connected it up, never used it yet.
How much was the extra?
About another £30, so like another 45 euros, something like that. And there was also a cassette interface. I think it could say about 5 bits per second, I bought. Not very fast, and a PROM programmer. And then after that, then we went obviously to the ZX80 and ZX81 and the rest of the series.
So I have a question about the original microprocessor, this SCMP.
Yes.
Is this something that you can get on eBay?
Yeah.
We are talking about buying old chips.
Old chips, the original chips. Yes, I want to have an original processor.
Yes.
You can sometimes find them on eBay. You find the CPU, there's an IO chip, that's I've never seen on eBay. So, as I said, there are companies that specialise in obsolete semiconductors. Usually one's only 20 or 30. So I contacted them and I bought a bunch from some old brokers. That's where I got them from. But this you will find on eBay.
Do you have an idea of how many of these chips are still available? Because at some point they will be hard to find.
So I bought 30.
Yes.
So exactly because of that worry. But I don't know how many are left in total. I was amazed what sits out there. What I would say is, so these are widely used. A lot of lifts, for example, use SCAN. A lot of control systems use SCAN. And the avionics and the military markets also use it, and that drives spare holding. If you think about trying to maintain a 30 or 40-year-old aeroplane that's got this kind of stuff inside it, that's a very difficult problem to try and repair. So these guys make a lot of money just by sitting on stuff in warehouses. But at some stage, yeah, obviously the stocks will run out.
And what do you think about doing the whole thing inside the PDA? Do you like the idea of, I understand what you have done, and it's It's really great to reproduce the original system, but the blue body, because maybe that was too much.
You could actually put all of it in a single FPGA, of course you could. The reason I didn't do that is because of the issue with soldering. So modern FPGAs come in packages you can only mount by machine, so it wouldn't be a hand solder project. So that if you've got a machine to do it, absolutely.
So the PA you're using is easy to solve?
Yeah, so let me show you. What's the photo on?
So it's
in a PLCC socket. So it's a 0.1-inch fixed socket. It's easy to solder by hand. But PFP or something would be very hard to do by hand. That's a great idea. So maybe you will be inspired to try it.
Well, I'm not very good with PCBs. Actually, I'm always concerned about making my own circuit with PAs because of that. But I know people like, maybe you know this project, TTX1 and CX1. They are building the board with the PA, and they can emulate in hardware Spectrum Apple II, for example.
So this would be it's a very simple computer. So it would be easy for them to do, absolutely.
And I wonder if maybe one of these small, let's say, FPGAs, yeah? Or
well, yeah. So the gate count on the scan, I don't know how many gates, there's not many. So for a modern FPGA, it would be very simple to emulate. So I don't know, I know people have done 6502 and Z80 and processors like that in FPGAs. I don't know if anybody's done Scamp yet.
Would be nice.
Maybe that needs to be done. But yes, it's a great idea.
Would be nice. I would check that. That's, because I didn't know about this CPU. It was amazing to know that it's a bit serious.
Yeah, to be honest, it's a pretty horrible programming architecture. It's not a very nice device to program.
I imagine.
So these, everybody has their favourites. A lot of people like the 6502, very nice software architecture. 68000, 68009, very nice software architecture. Scamp, horrible software architecture, but very cheap.
That's interesting. Okay, nice.
You said that the original chips cannot be found anymore. And do you know what is the reason?
Which chips? The CPU chips?
For the original chips, for building the original chip.
So you can find them, but not on eBay. You tend to need to go to a specialist broker, and they will sell you 20 or 30 of them, whilst there are still stocks left. So it's a good question. How long the stocks last? I don't know. But so I think yeah.
I have never seen an original kit of CX80 or 81. So I'm not sure of that.
So I've personally sold one of these together, and these came as the kits as well. I think Sinclair decided to broaden its market and be able to sell more of them. Most people were not going to be able to sell the kits together, so they started offering a service where it would be sold for you. And I think, I don't know how much you have to pay, maybe another 15 or 20 euros for it to be assembled. But of course the Spectrum, it was made at the factory, so there's no assembly required. All these three you could build as kits. Alright, okay. Thank you very much.
Thank you.
Thank you.